Welcome, everybody, to the AI Engineering Bootcamp Cohort 5. This is session number 7. We are in week 4, and it is already February already. So we've got a lot to cover today. This is a rapidly evolving space. And as you'll see, we'll be evolving some data today as well as we try to keep on the evolutionary edge of LLMs and how to actually evaluate stuff these days. Building, shipping, and sharing is going awesome. You guys are crushing it. Couple shout outs. Just we've been collecting all the great stuff you guys have been posting. So shout out to Ashwin, just straight up legendary. You keep posting. And also note everybody, these are LinkedIn posts. And when you paste them into something like a Canvas slide or something else, they show up with this nice graphic that's sort of a next level that you can kind of take it to. It's like they have the image associated with it. So yeah, I'm talking to you, Ben, because this was yours. You did an awesome job posting about your land graph, but you got that default posted on LinkedIn here. And if you post an app, it'll post that automatically. I also want to shout out some of the folks that we may have like missed shouting out in class, but shout out to the graders and to Jacob for tracking these down. Barath, way to go. Also, Krishanu, Deep T, you guys started posting on Twitter or on X, I should say. And, Lewis, also, you guys getting out there, getting after it. Love to see this. So I really love to see folks really representing their rooms. Lee's son getting out there, getting after it. Shout out to Jacob Kilpatrick, too, getting out there, getting after it. We did grade some of your homeworks as well. So, in terms of the homework number 3, you guys are still crushing it. This was the end-to-end RAG homework. 40 submissions, 14 of them were straight up perfect. And I want to give some comments over to, I believe this was Mike Dean. Mike, what did you see as you walked through this? Maybe a little feedback for everybody.
Well, just remember that when we're grading 40 assignments and we get 5-minute or 10-minute Loom segments, that's 40 times 5 minutes or 10 minutes that we have to listen to and make sure that we get all the way to the end. Because sometimes you have gems in your Loom movies that answer questions that we couldn't otherwise answer. So the key is make it 5 minutes or less at one time speed. And you should be able to do this. You don't have to go over the RAG diagram and spend 10 minutes detailing every flow that's in it. Just convey what you've done with the assignment, convey that you have an understanding of what's going on, and that's good enough. So a number of you were able to do this in 3 minutes. A few of you went over, I think one person or a couple people might have even had part 1 and part 2 Looms because Loom cancels you out at 5 minutes. If it cancels you out at 5 minutes and you're not done, re-record it because it's just easy to re-record. The other thing is that on the not sharing your work, if you share your work, you get a point. And at least half the people didn't do that. All you got to do is put it on Discord if you don't want to go on LinkedIn or whatever. And then finally, make sure your links point to the right place. My experience last cohort was that one of my Loom links pointed at my GitHub repository. 5 points off, gone, you're done. And that happened in one of the assignments that I graded last week. So just make sure your links are right.
Amazing. The retired professor and dean, Mike Dean, is reminding you guys to get out there and share on your social media platform. So thank you for that, Mike. Friendly reminder. And then we also did grade homework number 4. So Tyler graded this one. You guys actually picked it up. So more hundreds on this one. Close. Great number of submissions coming in. You guys are still really, really setting the tone. I love to see this kind of sharing. Tyler, you basically saw the same things as Mike, but overall, you're pretty happy with these, right?
Yeah. Yeah, I think it was a really great job by everyone. I mean, seriously crushing it with the answers for everyone and some really great posts out there. Um, I would say that, yeah, pretty much the same thing is just try to keep it 5 minutes and under while you have really good insights. Uh, if you try and stop your executive in the hallway and go into a 14-minute discussion, of why your product is so valuable, no matter how good it is, you've run out of time that they have overflow for. So it's really important to practice the sub 5 minute pitch. So that's all I have to say for that.
Love it. Thank you, Tyler. Awesome. And then, you guys have continued to ship and share with homework number 5. Shout out to everybody getting after it. We're seeing some great lessons. Again, refine these lessons. Things like an important lesson was the limitations of agents. Tell me more. And this could be a really, really awesome, great post to share with your network and folks at your day job or your university or whatever it is that you're doing on a daily basis. Multi-agent systems, you guys are already getting after it as well. Again, great lessons. See if you can clarify these to make them really, really super clear so that others can, pick up exactly where you're leaving off, and you can go ahead and build, ship, and share your way to some success. All right, I want to also just shout out some other folks in the community. DeepSeek R1 came out, and we had folks like Matul and like this was from Felix Ultima, and we had folks like Subom like sharing this immediately, and Wiz kind of convinced me, okay, we got to do DeepSeek as well. We're going to do DeepSeek next week, and the reason I'm bringing this up today is because if you can understand this idea of synthetic data generation that we're going to talk about today, it's just a hop, skip, and a jump to understand what it means for something to go through distillation, and for, everybody's talking about OpenAI got their sort of data stolen by DeepSeek, and then DeepSeek was also used to distill these open source models. So there's like these nested kind of series of synthetic data generation and distillation that's happening out in the world right now. And this is a really cool topic, and we're going to get some serious insights into it today if we go hard on understanding kind of exactly what's going on behind the scenes of doing SDG for evaluation. We also heard your feedback. Love the pacing, fire memes, pace content, excellent help. Okay, all that stuff's dope. Thank you so much. We love that kind of feedback. Breakout rooms are just so good. Keep that feedback coming. Loving the course, but I have to spend a lot of time and energy on going through the notebooks. This specific feedback we've been getting, I really appreciate you guys digging into the feedback to tell me more and more all the time. An additional Python app alongside the notebooks. We talked about it. We're not going to do this. We think you should have to do it. And I also love the idea that maybe you'll write a multi-agent application that does it for you. So we did consider it. That was a great proposition. It was nixed by the council. Okay, so you can talk to us more about that in office hours or in peer support hours if you'd like. Can we record breakout room sessions? Sure, just talk to your breakout room lead and work with them to make that happen. No issues from our perspective. Maybe some background on Python function, more notes on Python functions. Yeah, we heard you. We're going to put more notes on Python functions, so thank you for that. Back to feeling overwhelmed. Hopefully today is going to set you up feeling less overwhelmed. The examples are a bit simplistic. Hey, so it goes. We're going to really dig into that complexity as we start to get into working on our projects that we're going to present for demo day. I really like the advanced build options. Just some of the prompts to get us thinking about where additional complexity could be added. This is kind of an interesting idea, sort of trailheads, something that I'll continue to think about and noodle on as we continue to grow the advanced section of each notebook. This was a great question. Ask a question, get your answer. How would you add a human into this loop that is talking and giving feedback? Well, I would do exactly what Juan did, and I would also do exactly what Dogan did, copying Juan's GitHub repos. So shout out to whoever asked this question. Go ahead and build your own Jarvis. We've got the setup here. We've got folks in the community that have done it before. This is where I would begin. All the links are going to be in the slides. So check that out after class today. Special shout outs to Mike, Dean, and Mike Dean. Mike C, Mike Dean, we love you both. All right, let's get into it today. Aligning to the day, aligning to the week, what we want to do is we want to talk about synthetic data generation and evaluation. We want to talk about evaluation and SDG in that context. So what we want to do is we want to kind of get an overview of the assessment landscape and SDG for evaluation. We want to think about how to use SDG to generate high quality data that we can do evaluation with. And then we're also going to dig a little bit deeper into Lang-Smith to actually do the evaluation today. It should be fun. We're going to talk assessment, then we're going to talk how to generate this data, then we go to Lang-Smith. So today, LLM applications, they're complex. LLMs themselves continue to increase in complexity. As we increase in complexity, our applications, our LLMs, we're also using these LLMs often for evaluation. We eventually have to sort of cross this threshold, and we want to do that this week. Recall when we talk about RAG, we're talking about asking a question, go grabbing some data, throwing it in context, and getting a better answer. When we talk about agents, we're talking about asking a question, letting the agent decide, do I need to take an action? Maybe pick up a tool, then get my better answer. Maybe I need to look across a couple different tools to get some data, to have a little conversation with myself. Maybe I'll do a little function calling here in the middle, right? I'll do the reasoning and the action in one step right here, and I'll retrieve additional stuff. That's great for my question to be answered, okay? Really, at the end of the day. What is an agent? Well, we've talked about this. It's a system that's going to leverage that reasoning to make dynamic decisions in an application flow. But really, it's kind of fancy RAG, and we're giving it access to different tools and function calling and all that, and that's great. And in order to even talk about evaluation of some of these agentic applications, we have to talk about how to evaluate RAG in the first place, because if we do retrieval right, our generations are better. And evaluating RAG is really talking about doing retrieval right so that generations are better. This is where RAG assessment comes in. This is a tool that became a Y Combinator company in winter 2024. They've been working hard on this. This has really evolved over the last year. Shout out to the Ragus guys. It's evolving so quickly these days, it's really hard to keep up, and it's quite different than even the last time we taught this in cohort 4. So there are a couple of things you want to pay attention to in Ragus. You want to pay attention to the fact that we're going to leverage these prompt objects, these evaluation samples, and data sets. The prompt objects just allow us to essentially follow the best practices of prompt engineering, specific instruction, give it one shot, two shot, few shot, tell it what you want to put in, tell it what you want to get out. We've talked about all of this, putting the right stuff in context. When we put together samples, we need this to be like a piece of structured data that's going to allow us to evaluate our application. This is what it's all about. And there's two classes of evaluation samples: single turn samples that we'll use today, and multi-turn samples. I believe we're also going to play with this a little bit today, but those are kind of more for more complex applications. And single turn is kind of, you can think of it as perfect for RAG. Multi-turn is like if you have a bunch of tools and I need to do a bunch of different things, maybe I'll do a multi-turn thing. So you're going to set this up, and you're going to set up these samples in a very structured, nice way. Those samples will give way to larger data sets. They're just collections of samples. And we want the samples to be consistent. We want them to be aligned with the stuff that we're trying to assess. We want them to be representative of the data we expect to see in production. And we want them to be, of course, high quality, right? Data in, garbage in, garbage out. Okay, so Ragus, what we're going to use it for today is just for generating this test data. So what we want to do is we want to generate some synthetic test data that's important to RAG. So we think, well, what's important to RAG? Well, the question and what we put in context and the answer, right? Well, that's right. But wait, why are we even doing this exactly? Well, it's going to allow us to do this more quantitative approach. More than a vibe check, we're doing this metrics-driven development. We've talked about this before. We want to establish the baseline, we want to change stuff, we want to recalculate and see if we improved the baseline. So we might get some key metrics out of our RAG application. We might look across all of the different pieces to our RAG application. We might decide to change some of them, or to augment them, or to enhance them, or to swap out models, or to fine-tune models. Eventually, we're going to come across a nice setup that really gets the job done. We're going to be all systems go. Ragus can help us with this. And actually, what we're going to do today is we're actually going to kind of have Langsmith help us with this. Well, let me be more specific. Ragus can kind of help us draw this sort of box in this space, and it can do it with data. So what we're going to do is we're going to need data to test our app. And that's where synthetic data generation comes in. We're going to need to generate some sort of question, context, answer data with which to say, hey, does this look right? Does this look good? Are you able to answer these questions the way I would want you to be able to answer these questions, RAG application? And then what we're going to do is we're going to do actually the evaluation of that data today with Langsmith. You can use sort of anything to do these evaluations, but the synthetic test data generation, that's a very sort of niche specific thing. And we believe that Ragus is the right tool for the job there. We'll talk Ragus metrics and Ragus evaluation next class. So SDG, synthetic data generation. Here we're doing synthetic test data for eval. But in general, the idea of synthetic data generation is to just literally increase developer velocity. In this case, with Ragus, we're trying to do it, again, for evaluation. But again, if we zoom out, whether we're training models or we're refining our applications or the models within our applications themselves with synthetic data, it's all about using SDG to do stuff that mimics the real world and to sort of take away the problem of it takes really long for humans to collect data. Now, it used to be that last time we taught this class that we evolved these test sets, and we still kind of do, but it's not as straightforward. It used to be literally an evolutionary algorithm that did this synthetic data generation. It was from this wizard wizard LM, this eval paper with the eval instruct framework that basically started with an initial set of instructions and then used this framework to evolve the instructions. And this was pretty cool. It did it sort of breadth-wise and depth-wise, and sort of you could start with an initial instruction like 1 + 1 = what, and then you could sort of do all these different things to make it sort of more interesting. But you can kind of see the single hopness of this all. You can kind of see that although you can do a lot of in-depth and in-breadth evolving, I'm not really seeing the sort of multi-step nature that I might need for something like an agentic application at play here. So this is where the new method of doing SDG has come to fruition within the Ragus framework. We're going to cover it today. In general, we want to generate some data, we want to run the evaluation, we want to change some stuff, we want to rerun the eval. In general, with RAG, we're going to have a question, an answer, some context, and then we're also going to want sort of the reference answer, the truth, right? The oh so elusive ground truth. So how do we actually generate this data with the new framework? Well, to generate this, we're not going to use the old process where we would validate the chunks and generate the questions and then critique them and then generate the answers. and then the ground truth. Rather, what we're going to do is we're going to use a knowledge graph. And this is, again, because agents with this more complex setup, this previous method was sort of leaving us wanting, and really this is a very, very edge space. We're not exactly sure how to do the agent evaluation in general yet, but it definitely is going to lend itself, this knowledge graph approach, to more multi-hop solutions and to just kind of a more structured approach. Although still technically, we're kind of evolving the data with prompts under the hood. Okay, so what's the process? Well, it probably looks pretty similar to ones we've seen before. We're going to instantiate a graph. We're going to add some nodes to it. And then that's where things start to change a little bit. So once we do that, we're going to essentially do some transforms on the nodes. The resulting knowledge graph is going to allow us to get that data. That's going to allow us to do the testing. Those transforms we do on the nodes, there's some default ones that we're going to do out of the box, and we'll see this. Producing summaries, extracting headlines, extracting themes. Once we have these transforms, we then use this cosine similarity approach and some heuristics between the embeddings of these transformations to construct relationships between nodes. Graphs, all about those relationships. Once we have these relationships, once we have this knowledge graph, we can just use the graph, and we can use, this is a dope name, query synthesizers, to just whiz up some LLM test data, okay? And then we're kind of doing the same thing we were doing in the evolutionary space. We're just saying, hey, we're going to generate some data. But it's kind of cool how they do it here. The LLM generates a persona, and then the persona is basically the role, right, in best practices in prompt engineering. It's just someone who would interact with the data, somebody at your company maybe. And then we're going to use the scenarios along with the persona to construct question, answer, etc., that we can use to test. We're going to use some data from a set of blogs on the State of AI 2025 from Simon Willison. And we're going to use some models that you guys are familiar with. So I'm going to hand it off to Wiz to show you exactly how this works. The first sesh of the day is going to be focused on just the test data generation with Ragus. Let's see how the knowledge graphs are working on the inside. Wiz, over to you.
Oh yeah. Okay, so this is the first thing we're gonna do is we're gonna say the word graph a lot of times in a row in order to familiarize ourselves with what kind of graph goes where. So we are going to be looking at a knowledge graph, which is going to contain a bunch of nodes and edges, just like we're used to. But this time they're all going to be entities and relationships. This is not similar to Lang graph, which is going to be a directed graph, which still has nodes and edges, but it's more about the flow. So what we decided before the session was knowledge graphs are like social networks, and Lang graph is like a flow chart. That's what we're going to stick to. Okay. But our knowledge graph is incredibly useful because it's going to help us understand the relationship between the nodes in our database. So let's figure out how to make that by zooming in, and then we'll go from there. Okay. First of all, if you're running the notebook locally, please do not worry about this. You do not need to install these packages. They're already part of the UV environment. If you're in Colab, please make sure you install these. There you go. Okay. We're going to provide our LangChain tracing v2 to true. This is all we need to do for tracing to work. And then, of course, we're going to get our LangChain API key, which is going to be what we need to connect to a cloud, the Smith cloud platform. We're going to name our LangChain project whatever we want. In this case, it's going to be AIM SDG with some random characters. And then we're going to, of course, use our OpenAI API key because we need that in order to power our LLM. Okay, so we're going to generate some test data. Now, this is the kind of like the best part of this space, right? We have these extraordinary thinking machines that can think extraordinarily, and the idea is pretty straightforward. We can use them to craft data that we should hope can be can be implemented by our RAG application. So what we're going to do is we're going to basically get the LLM to produce questions and answers that we think are worthwhile or should be within the list of questions that we want the system to answer. I see this very annoying pop-up, and so I'm just going to get rid of it very quickly about logging in from a different tab. Many apologies for this pop-up being kind of troll. Okay, so basically, we'll just give her the old refresh. Should be ready to rock. Here we go. Okay, cool. The idea is straightforward. LLM make data for us. But like, we want that data to be challenging, right? We want the data that we create to be difficult, right? We want it to be something that is not simple, right? Because we hope our RAG application could do simple stuff. I mean, that's the whole point of it, right? We want to see if it can answer questions that are more difficult or perhaps require more than one reference to get correct. And that's why we're going through this kind of very involved process to create that synthetic data, right? You can imagine that the more complex our systems get, the more complex our synthetic data generation pipelines need to be in order to support data that can meaningfully evaluate those systems. And remember, our application just retrieves context and answers a question, right? And we're already having to think outside of the box on how we can do generation well. In order to do generation, we're going to break a cardinal rule of machine learning, okay? Which is that we are going to use the data that we know is going to be in our corpus, right? So we're going to leak the test set, essentially. Because what we want to verify is that their system can answer questions about that data, and it can answer them well. So in this case, it's not evaluation as we would traditionally use in machine learning, where we need to hold out the test set until just evaluation, right? We're actually going to go ahead and test the system on this data, right? So we're going to set up this data in a way that like a user would use. So we first just download some stuff. We've got two pretty cool blogs. They're about the state of AI, both in 2023 and 2024. And then we're going to go ahead and load them using our directory loader from LangChain. And then we're going to start by making some synthetic data using our best friend Ragus. We're going to do a wall of imports. Importantly, LangChain wrapper just wraps the LangChain LLM. LangChain embedding wrapper, you know what it does. It wraps the embedding wrapper. And then chat OpenAI and OpenAI embeddings are the actual LLM and embedding model we're going to use today. You're going to see that we are going to use the embeddings wrapper, which is, pretty important. Okay. We're going to start with an empty knowledge graph. Just like we normally do, we're going to start with just some canvas, and then we're going to start plopping nodes onto it. So you'll see that the initial knowledge graph has absolutely no nodes, no entities, and it has no edges, no relationships. Okay, cool. So we're going to go ahead and we're going to add our two documents. We're adding the whole document here, right? So this is important, right? We're not just adding like a chunk. We're adding the entire document, which is quite large. We're going to take advantage of some of the cool features of these LLMs that we have today in order to do this well. Then we're going to apply some transformations to each of the nodes in our graph. What this is going to do is it's going to produce a couple different kinds of sub-documents, right? So for each document, we're going to create some summaries. we're going to create headlines, and we're going to create some themes. The idea here is pretty straightforward, right? When we look at the default transforms in Ragus, it's basically just, we have this default set, right, which is going to be our summaries, key phrases, titles, headlines, and embeddings, right? We can look at the actual code itself if we wanted to get into it, and we can see how it's doing this. The big idea is that, if we have some some small subset of documents, then we're going to create some headlines, some themes, some an extract using NER, which is named entity recognition, and then we're going to do some summary embeddings. We're going to do some relationships between those summary embeddings. However, if we have these much smaller documents, we're going to use a different set of default transforms. The basic idea here is that we are going to just collect a bunch of information about each of these nodes. That's what that transform is going to be. So it's going to take our base node and it's going to turn it into a bunch of nodes. So let's see how that happens, or let's see what that winds up being. So we go from our 2 nodes to 14 nodes. So we've added 12 new nodes to our knowledge graph, and then we have connected these nodes by their relationship. So what is the relationship between each node and each other node? Very important to know what the relationship is, right? The idea is, if we know what the relationship is, then we can make some kind of assumption about, how we should interact with this. We can save our knowledge graphs and then load our knowledge graphs, which can be handy, always fun. Finally, we're going to use our test set generator. Now, our test set generator is going to do what you would expect it to do. It's going to generate some test data. Someone asked in the Zoom chat, why are we generating questions? Why do we care, right? The idea is we know our RAG system is going to be operated by people in a way that they will ask questions of it, and then they will receive responses from it. So we're trying to effectively build a set of questions that users might ask in a way users might ask those questions, and then we're going to get some ground truth response, which we're going to see in a second how it happens, and then we're going to get some kind of context, some golden chunks, right, which is very important for what we're going to talk about once we get into next week or next session. But for today, all we really care about is that we need to generate some questions. So we build the dataset generator. We're going to pass in our generator LLM. We're going to pass in our embedding model and our knowledge graph. And then we're going to decide on what kind of queries we wish and what distribution we wish for those queries to be in. So this is something that is very specific to Ragus. It's kind of like I would say it's like their thing, right? So this is what Ragus has been kind of good at doing, is coming up with these different kinds of flows, right? So we have the idea that we have a single hop specific query synthesizer, and I'm gonna say all of these words, and they're a mouthful. And then we have a multi-hop abstract query synthesizer, and then we have a multi-hop specific query synthesizer. Okay, and the idea is that these represent different kinds of questions that users might ask. So, when I'm looking at my questions or my documents in my corpus, I don't want to just ask all single hop specific queries, right? I don't want to just ask say my documents have the answer to the question, what is the capital of France, right? Like I don't want to just just look at that as all of my questions I test with. Sure, maybe we can say a large portion of traffic will be simple questions like that, right? But what about if the query is a little bit more abstract, right? It's not like directly answerable by the system. There's some kind of inference that must be made, right, based on the provided information. And same thing with, what if it's not just in one document, right? What if the actual question pertains to more than one document in our corpus? How do we handle that, right? And so this is what the idea of these query distributions are. It lets us say, hey, we've got n queries, whatever it happens to be, and we want to make sure that some 50% of them are easy, right? But that 25 and 25 are, very hard and reasonably hard. And this is going to come into play in just a second when we look at what's happening. And I'm going to do something very fun for some of you and perhaps a little bit overwhelming for some others, which is we're going to look at some actual code, but realistically just the prompts. So you can see here that we have, for our query answer generation prompt, right? We have generate a single hop query and answer based on the specified conditions, persona, term, style, and length, and the provided context. Ensure the answer is entirely faithful to the context using only the information, and then we're going to generate a query based on that persona and then generate an answer that can only be answered by the context that the query was generated for. So this is the kind of thing that we're doing behind the scenes, right? This is for the single hop query. If we go back to our synthesizers and we look at our multi-hop, we can see form combinations like pairing concepts for at least 2 different lists. Review the concepts from each node. Identify concepts that can be logically connected or contrasted. Form combinations that involve, you get the idea, right? What we're doing is we're saying, hey, we've got more than one node. Let's ask a question that can only be answered by having information from both of these nodes. And so that's what all of this is doing. It's telling us exactly what kinds of queries we have, and it's telling us exactly what kind of queries we care about. Okay. Now we can let her rip. We can define the test set size and then provide our query distribution and then let it generate. It's going to first generate some personas. This is going to be personas that would be asking questions about this content, right? So let's just have questions that are fairly simple and straightforward, and also questions that are perhaps more technical and specific. We have scenarios, which is why would a user be using this, right? What's the point? What are they trying to do? And we look at the prompts, and we just go back to the single hop example, right? We look at the prompts. We're taking this into consideration when we're constructing the question, right? We care about why the user is using this, and we care about who the user is when generating those questions, which should lead naturally to better questions. You'll also see that we have things like this. What is the California Academy of Sciences? And so you'll notice this is terribly misspelled. You'll notice that this one is all lowercase. The idea is that we're going to introduce some noise into our question, right? We're going to introduce some users. They're not the best spellers. They're in a rush. They're mashing the keyboard, right? They might be adding extra characters or whatever. And so this persona lets us have this kind of noise, which also lets us test how resistant our system is to that noise, right? So we know that this is particularly noisy, and we can use that information to infer then that our system is more or less resistant to noise. We're going to see that metric on Thursday. For today, we're going to keep it a little bit a higher level, but that's the idea, right? That's all we do. We create this knowledge graph, which understands the relationships between the different nodes. We create some idea of extracting or transforming those documents beyond just their base form. So we're not just using the test set directly, right? And then we build queries that fall into this distribution that we design that is relevant to a specific persona and trying to do a specific thing. Okay, all of that's great, and there's a lot of code to do it. And Ragus does let us do it without all of that, which is just these 2 lines. So we have the unrolled version, right, which is showing us step by step what's happening. But if you just want to trust in the system, you can go ahead and use these 2 lines, and it's going to do the same thing, right? But we want to understand what's happening behind these 2 lines of code, because as we've just talked about for quite a while, there's a lot going on, okay? So that's the idea of synthetic data generation with Ragus. I'm going to pass you guys back to Greg, who can get us into our breakout rooms.
All right. Thank you, Wiz. Hey, Wiz, I've got one question for you. Okay, so
Yes.
when we're doing this synthetic data generation, we've got the question, we've got the context, and we've got the answer. And I wanted to just clarify, because this was confusing for me for a long time. Are we just using our app to get our reference answer right now? or is there a correct reference answer right now?
Yes, we have a correct, well, we have what we would assume is a correct reference answer, which is going to be generated as part of this process. So we're going to generate both questions and answers. We're going to rely on the fact that the answer generated by the LLM during the synthetic data generation process is correct. The reason we assume that is because there's this kind of like rule, right? If we give the LLM the correct context, it's almost certainly going to be able to answer the question correctly, especially when they don't involve advanced reasoning, all this other stuff. And we know that it has the right context because the question comes straight out of the context, right? So we say, hey, we've got exactly the context and question pair. We're going to have the LLM generate a reference, which is going to be like our ground truth response.
That's right. That's right. So we'll need to track especially when we move to other tools like Langsmith, terminologies, but there's always going to be a question, context, an answer that our app spits out, and then like a truth or reference answer that we want to make sure that we notice is different. Okay. Very cool. I am excited to go ahead and introduce this next breakout room for you guys. There's also a bonus activity here. Essentially, all you got to do is use Ragus to generate the synthetic data. But if you want to dig into exactly how they used to do it, right, and you want to go build your own LangGraph agent to actually do the synthetic data generation, this could be a very useful thing. One of the things that's worth noting is before Ragus actually had some SDG stuff, it was the kind of thing that Wiz would just write his own script to do. This is something that you can always do. You don't need to rely on out-of-the-box tools, although they're getting better and better, and maybe you should. So check it out. Hope you guys like it. We'll see you back in a little bit for a break. Have fun with your breakout rooms. See you soon. Discussion. And we're back from the break. We had a great discussion on the break. I think there's lots of room for amazing community sessions to even go deeper on all this copyright, terms of service stuff, distillation, fine-tuning, SDG, lots of good stuff here. Today we are focused, however, on evaluation with SDG. And where we want to go now is we want to go to our good friend Langsmith. So remember, we had SDG data, question, answer, context, ground truth. Now I'm going to throw a little bit of a curveball at you because Langsmith doesn't like these terms. Just like when we talked about system user assistant, they're going to use something a little bit different. System, AI, human. Now, here I've X'd out the terms that Ragus was using, and I've put terms that you'll find in Langsmith. And you'll notice that actually where answer was before, we see answer right schmear. And so we have to understand the concepts and not get too hung up on exactly what the terminologies are. And we have to track the right things in the right places. What are we doing? Well, we're just going to set up our Langsmith data set using the synthetic data we've generated. We're going to build a RAG chain because we're great at that now, and then we're going to set up our evaluators. Now, what we're going to do is we're going to be able to actually use evaluators that use labels like answer here, right? And we're going to be able to go ahead and build our basic RAG chain, set it up with key metrics. Those are going to be our Langsmith evaluators. And here it's time for just a little bit on some of these evaluators in Langsmith. There are essentially three types. Langsmith is not totally focused on evaluation like Ragus. Langsmith is a fully end-to-end platform. They have question-answer evaluators, criteria evaluators with and without labels. So when we talk about QA evaluators, they have, and the one we'll use today is just simple correctness. Is it correct or not? Yes or no? There's also some additional, more complex ones that I encourage you guys to check out. So correctness is what we will use. Additionally, we're going to use a simple criteria evaluator. And these can come with or without labels. Let me show you the example of accuracy. Anybody can prompt an LLM. It's similar to a vibe check. Hey, how accurate is this prediction on a scale of 1 to 10? It'll give you an answer. So this is a criteria evaluator without labels. With labels, we might use some reference material. We might use some input reference, some output reference. And notice here we have answer, we have input, output, reference. We have to track these terms from one framework to another. But again, it's the idea. Which one's the answer coming out of my RAG application? Which one's my ground truth answer? How accurate, rather than just on a scale of 1 to 10, is this prediction, boom, compared to the reference on a scale of 1 to 10. And in this way, we can do this kind of thing. We can also do custom ones, and we will do a custom one. The classic dope or nope is what we'll do. And we'll ask about this kind of output we can get from Simon Wilson blogs. Are the outputs dope or nope? So let's do some assessment with Langsmith, with our SDG that we generated, with Ragus, putting it all together. Over to you, Biz.
Oh, yeah. Okay. And you might think at this point, man, we sure are talking about evaluation a lot, right? And we 100% are. Evaluation is the thing that separates us from just throwing spaghetti at a wall and hoping that it sticks, right? Evaluation is integral, core part of the job, core part of the whole kit and caboodle. It leans so hard on this because we need a way to say application better, application works, right? And we need a way to be able to do that in a repeatable, verifiable way. So that's why we're using Langsmith today. We're going to get a little bit deeper into Langsmith. We've seen it, we've heard of it certainly a lot, and we've seen it once or twice, but we're going to get kind of a little bit deeper into it. First things first, we've already been Smith and Langs this whole time. So the moment that we started off, this is the the top of the notebook here for everyone's favorite thing, tons of scrolling, and you'll see that as soon as we did this, LangChain was going. LangChain was out there. It was doing cool stuff. It was collecting traces. This is the beauty of Langsmith, right? It's already going. Okay, it's already collecting traces. If we're looking at our let's say if we're looking at our Langsmith dashboard and we look at like these SDG things, you'll notice we have like hundreds of traces, right? Themes and content, NER prompt. What's all this stuff? Well, this is all the stuff that built our Ragus data set, right? So we have here NER prompt, right? This is the thing that actually we used to generate some of the synthetic data. So even that was tracked by Langsmith, right? We got the trace. Let's have a quick walkthrough of the trace dashboard in Langsmith. Okay, this is the this is like where the magic happens, quote unquote, right? We got a lot of really interesting, I'll just zoom in just a little bit more here without trying to break the UI, but you can see here that we have how many runs, how many tokens, how much this cost us, right? So this, everything that I've done in this notebook has cost less than $1. Let's go. We have the median number of tokens we've used per request, how many times we hit errors, our P50, P99 latencies. This is like, in the worst case, how long does something take? And then in about most of the time, how long does something take? Then we have, I'm going to zoom out just a little bit so we can see it better. We have the actual calls. We got tons of filters. We got tons of additional information that we can look at, right? We can look at, say, actual usage information. We can look at, what our threads were doing if we had any. We can look at everything per runs. We can look at what each of these things is doing, right? When it did it, how it did it, what model it talked to, what model version it talked to, et cetera, right? This is the idea of Langsmith. It's just a big old dump. We just dump traces in there. Now, these traces are extraordinarily important. We are going to get a little bit deeper into this next session but just to freshen your minds, this trace says everything that has happened, right? And so when we're looking at evaluating this thing, we're going to use the word holistically, right? When we look at evaluating this in its entirety, we want to be able to not just evaluate, say, end to end, but maybe we would like to evaluate, like, how did this step do, right? How did this step do? How did this step do? And that's the power of these traces. It lets us dig into that. Additionally, the Langsmith is great for evaluation, as we're about to find out. We have the ability to both provide automated evaluations, and also we have the ability to have human annotators come in here and annotate some of this data, right? So you have SMEs, and you want to get that golden data set as generated by the human mind, you can do that. There's so much we can do with Langsmith. We're not going to be able to get into all of it throughout our time together, but it is something well worth diving into. We can create dashboard. Everyone loves a dashboard. And then we have our data sets and experiments. This is where we're going to spend a lot of time today. Okay, so going back to the notebook, we're going to create our client, and then we're going to create a data set. So let's say we wanted to create a new data set. We're just going to do the old classic. We're just going to go ahead and run this and create state of AI across the years of V2, right? Because we already had V1. What we can do is look at our data sets, and then it will populate here once we start running traces through it. But the idea is that we can create a data set on the Langsmith client, and then we can add examples to the data set, right? So we can push a bunch of stuff to this data set. Essentially, just offloading it onto the Langsmith server. Each of these traces is going to count against your monthly limit. So please keep in mind that, the free version does have a set limit of traces that you get per unit time. I think it's like 1,000 per month. You might think that you won't use it. We had a learner who blew through the limit and then some because of the way that they were doing their project. So be a little bit sane with Langsmith if you want to stay within the free limit. But the idea is that we can use this process to just push data to Langsmith, and then we should be able to see that start to populate here as we do some more work with it. We're going to build a basic chain because we have to. The basic chain is just going to be 500 character long chunks with 50 character overlap. We're going to use text embedding 3 small. We're going to use quadrant, same as always. We're going to use search quargs k equal to 10. And then we're going to go ahead and we're going to build our RAG prompt, provide our brain, GPT-4o mini, and then, of course, we are going to build that RAG chain. This can be anything. It could be an agent, it could be a Langsmith graph, it could be anything. Okay. Then we can ask it questions like, what are agents, right? They're classic. What we're going to do now is evaluate this chain, right? So what do we need to evaluate? Well, Greg alluded to it already. We have context, right? We have question. We have reference answers. All we're missing is what the heck does our thing do, right? What's the context that the RAG pipeline gets? And what is the answer that the RAG pipeline gets? You'll notice that we're going to pull both of those out of this chain, which is very handy. And what we're going to do is set up some evaluators. These evaluators are based on the string evaluator from Langsmith. The idea is we have like a QA evaluator. This is going to answer or evaluate our question answers. Then we're going to have our labeled criteria. This is a custom metric. We are creating this, and we are saying this should be helpfulness. Is this submission helpful to the user? These things here are actually this is a prompt. So this right here is a prompt to the LLM, and we'll verify that in a moment when we look at our actual evaluations. And then we are going to see a prepare Lambda run example, all this other stuff. The idea is that Langsmith expects there to be a prediction, a reference, and an input for this particular evaluator. And you'll notice that this particular evaluator, the way it's provided by the Ragus synthetic data generation, does not actually have the same column names, so we just have to change those. Easy peasy. So we map answer to reference, we map question to input, And then for our run, we're just going to take the output very easy. And then finally, we have a criteria that is less, involved, and this is going to be the dopeness evaluator. Is this submission dope, lit, or cool? Okay, very, very awesome. Your activity is to tell us what those are doing. Talked about it a little bit, but you can go a little bit deeper. And then we're going to evaluate. We use evaluate. We pass in our RAG chain. We pass in our data set. We pass in each evaluator. We give it some metadata to know what revision this is, and then we get some response with some metrics. This is cool. They give us the output, but it would look cooler here, so we can look at it here. We can look at our first evaluation, and we can see how it did. We can see that, overall, correct. We're seeing a lot of back and forth, right? Dopeness, a lot of not dopes. Helpfulness, a lot of not helpfuls. Right? So we want to see if we can improve this a little bit. Once again, we can click on each individual run or trace and see exactly what happened in it. Very cool. We can see what the reference was, what our input was, and what the output was to do manual, manual verification. We can look at the full. If you want to look at full, we can do whatever we want. It's all good. Okay, so that's that. Very cool. Hugh asks, does every cell produce a query to open? I'm not sure what that means, but every evaluation gives you this entire dump, if in case that's what you mean. Okay. Now, this was good, but it wasn't very good, right? Especially on dopeness. We saw it lagging behind. So we need to make some changes. And what we're going to do is we're going to change our RAG prompt, right? We're going to change our RAG prompt to encourage it to be in a dope, state of mind. So answer the questions in a dope way. Be cool. This is sure to work, right? And then we're going to also make our chunk size bigger, right? Maybe that will do something. Your job is to answer what might it do, and then we're going to use a bigger embedding model, which might do something, and your job is to answer what might it do. And then we're going to do exactly the same chain for the rest of it. And we're going to evaluate it right again. Same exact metrics on the same exact test set, right? Just let her rip again and then go back to our actual results. And when we look at our results, we see improvement across the board. Correctness goes up, right? Dopeness goes way up. Massively increased dopeness, and helpfulness increases a little bit. It's still relatively not helpful. Something we would definitely want to look at. But what Ragus has done, right? What LangSmith has done is it's given us a way to say our app is more correct on this test set, and it's more dope on this test set. And that's what we need it to do. We need it to be able to say that so that we can be sure that the change we made certainly didn't degrade performance. So yeah, users will be our ultimate judges, but for this, it's a great way to say, like, these changes certainly didn't seem to regress things. It's worth pushing it to prod and getting that valuable user feedback. With that, I'm going to go ahead. I'm going to pass you guys back to Greg, who will get us into breakouts.
All right. Yeah, let's ship it to prod, baby. Users are the best testers. So I think, one of the things that's so interesting as we think about how to actually improve these systems, and it's sort of a problem with business in general, is, you can sort of generate this test set data and you have this test set data. And then as you evaluate and you try to improve, it's like, what are you going to change? And, you can change one thing at a time, and it's sort of like the classic approach, or you can kind of just throw stuff at it and see if it improves. And, you can probably get rewarded pretty highly for either one of those. So, especially out here when nobody's really sure exactly what's going on, we're using synthetic data off the jump anyways, it's very, very difficult to really say what is the best method or technique. But, if you have lots of stuff that's quickly at hand, just, quickly try lots of stuff and maybe one at a time sequentially and see how things improve. And this is the general theme that we're going to get into when we talk about advanced retrieval techniques and when we talk about how to improve RAG systems in general and get them to that production ready level. Don't forget, we also have the one-on-one support available. And if you need to join, please do. Otherwise, Have fun with your breakout rooms. We'll see you back to close out session number 7, SDG. See you soon. Test. Welcome back from breakout rooms. It's time to wrap up session number 7 on synthetic data generation. We focused on SDG for evaluation today. We talked about really when you're doing eval today, you're probably going to leverage SDG. You're probably not going to create that perfect golden data set with all the humans and they give you exactly the perfect amount and the perfect type. Although you should also remember, it's very important to talk to users, get it in users' hands, get their feedback, start collecting data with them, and you can start synthetically generating data based on that feedback. But in lieu of all of that, you can just take your context and dump it into an SDG generator, get numbers, and they can go up and they can go down when you change stuff, which is very, very useful for any of your bosses or anybody that wants to see improvement that's directional. When we use SDG for evaluation, keep in mind that the answers and the references are different. We want to track terminology when we go from something like Ragus to Langsmith or to Llama Index or to anything else. We want to make sure that we're tracking what the language that they're using is while keeping the conceptual ideas top of mind. And as we talked about during the break, if you're going to do distillation, if you're going to do SDG fine-tuning, which these things are not strictly speaking exactly the same, but I would say that if you're going to do that, definitely use an open model, a truly open model, not OpenAI. Lots of ways to leverage SDG, lots of conversations we can get into around this. It's a very popular topic these days. And we look forward to discussing all that stuff in office hours with all you guys. Hopefully see some of you guys on Thursday. Next week, Vincent's going to go deep on evaluation. If you joined him today, maybe you can see him next week for more as well. We'll talk Ragus on Thursday. In the meantime, we hope to see you tomorrow. We'll talk small agents live on YouTube. And with that, it's time to give us a little feedback, everybody. We'll put 2 minutes up on the clock, and we'd love to hear what you thought about today and how we can improve on SDG for the future. Thank you, everybody, for joining us for session number 7 on synthetic data generation for eval. We look forward to keeping the SDG discussions going with you guys. Join us Thursday for RAG assessment, digging into the metrics for RAG, for agents, and we'll talk more about how we might actually evaluate some of these real multi-hop applications that we build with agents. We're going to bring it all together on Thursday to get you fully up to speed with the state of the art in eval. If you have questions, please jump into Discord. Don't forget to build, ship, and share in Discord, on X, and on LinkedIn at AI Makerspace. We will amplify. Looking forward to see you guys on Thursday and maybe even tomorrow on YouTube Live. Thanks, everybody, for joining us. We will see you guys real soon. Bye, everybody.
Bye, everyone. Take care. See you Thursday.
Later, guys.
Bye.
Want us doing meta? Can I show something funny?
Yeah.
Do it.